Hi students, welcome to Lakshya Academy YouTube channel. In the previous video we discussed basics of logic gates. Okay, we continue that part, logic gates. Generally in digital electronics they consider a transistor and a resistor. Using transistor and a resistor, a transistor and two resistors, they design a logic gate, that is NOT gate. NOT gate has one input and one output. If input is 1, output is 0. If input is 0, output is 1 in the case of NOT gate. So using a transistor and two resistors, NOT gate can be designed. The truth table of NOT gate: for input 0, output is 1. For input 1, output is 0. Symbol of NOT gate. Using two transistors and three resistors, they design another logic gate called as AND gate. AND gate has two inputs, A and B, one output, and both the inputs are 0, output is 0. Input A is 0, B is 0, output is 0. Input A is 0, input B is 1, output is also 0 in the case of AND gate. And third case, input A equal to 1, input B equal to 0, the output of AND gate is also 0. Case 4, if input A is 1, input B is 1, the output of AND gate is 1. So precisely in the case of AND gate, when both the inputs are equal to 1, the output is 1. In all other cases, output is 0. Truth table of AND gate: when both A and B equal to 1, output is 0. Using two transistors and three resistors shown in the diagram, they design another logic gate, that is OR gate. In the case of OR gate, both the inputs are 0, the output is 0. Case 2, A is 0, B equal to 1, output is 1. Case 3, A is 1, B is 0, output 1. When A and B are 1, output is also 1. In the case of OR gate, when either of A or B equal to 1, the output is 1. When both equal to 0, output is 0. Truth table of OR gate. In brief, the truth tables of the three basic logic gates, NOT gate, AND gate and OR gate, are given. Next, combination of logic gates. Students, already I mentioned that there are three basic logic gates: AND gate, OR gate and NOT gate. Using three basic logic gates, we can get a new logic gate by combining these three basic logic gates. That is, combination of logic gates or combining of logic gates using three basic logic gates in digital electronics. Okay, once again I mention that the truth table of NOT gate. A is input and Z is output. Z is output. And truth table of AND gate, A and B are inputs and Z is output. So when A and B are equal to 1, Z equal to 1. In all other cases, Z equal to 0. Next, OR gate, the basic logic gate OR gate. A and B are inputs, Z is output. So when both A and B is 0, output is 0. In all other cases, output is 1. Next, first example, combination of OR gate and NOT gate. A and B are inputs of OR gate and C is the output. According to the truth table of OR gate, we can write the value of C. And C is the input of NOT gate. Z is the output of NOT gate. So if C equal to 0, Z equal to 1. If C equal to 1, Z equal to 0. So this is the combination of OR gate and NOT gate. Z is the output of the combination. This is first example. So NOT and OR, NOT OR. So this is called as NOR gate. Truth table of NOR gate. NOT OR combines NOR. In the second example, I consider AND gate and NOT gate. A and B are inputs of AND gate. C is the output of AND gate and Z is the output of the combination the combination of the output of the combination, and C is the output of AND gate. So Z is the output of NOT gate. So when C equal to 0, Z equal to 1. When C equal to 1, Z equal to 0. So this is NOT AND gate. So this can be named as NAND gate. This is the truth table of NAND gate. Next, third example, two NOT gates and one OR gate combined. A and B are inputs of two NOT gates and C and D are inputs of OR gate. Z is the output of the total combination. So for A equal to 0, C equal to 1, A equal to 1, C equal to 0. For B equal to 0, D equal to 1. So C and D are inputs of OR gate. So Z is the output of OR gate. So when both are 0, Z equal to 0. When C and D either equal to 1, Z equal to 1. So this is the truth table of this combination, two NOT gates and one OR gate. This is the third example here. In the fourth example, I consider two NOT gates and one AND gate. A and B are inputs of NOT gates and Z is the output of the combination of the output of the combination. C is the output of A and D is output of NOT gate for B. So values of C and D can be written easily. So Z is output of the AND gate of C and D inputs of AND gate. So Z equal to 1. This example 4 is the combination of two NOT gates and one AND gate. Next example 5, one OR gate and one NAND gate. They are connected like that. A is the input to the AND gate and B and C are input of OR gate. So here 8 possibilities are there for B and C. D is the output of OR gate. So the output of OR gate can be written in the tabular form as D. So A and D are inputs of AND gate. Next, the combination of AND gate and OR gate. B and C are inputs of AND gate. D is the output of AND gate. A and D are inputs of OR gate. Z is the output of this combination. So when A and D, either A and D equal to 1, Z equal to 1, so the values of Z shown in the tabular form. This is example 5. Next, example 6. 2 AND gates and 1 OR gate combined as shown in the figure. A, B are inputs of first AND gate. A and C are inputs of second AND gate. D and E are inputs of OR gate. So combining A and B we get D. Combining A and C we get E. So D or E is Z. Z equals D or E. Next example, AND gates and NOT gate joined as shown in the diagram. A and B are the inputs of first AND gate. C is the output of that. So C is expressed as A and B. So C can be written in the tabular form. B is the input of NOT gate. D is the output of NOT gate. So the values of D can be written. C and D are inputs of AND gate. When both C and D equals to 1, Z equal to 1. Next example, 2 AND gates and 1 OR gate. AB are inputs of first AND gate. E is the output. CD are inputs of second AND gate. F is its output. E and F are inputs of OR gate. Z is the output of this combination. So here 4 inputs are there. So 4 square input combinations are possible. Next, 2 AND gates, 2 NOT gates and 1 OR gate. C is not A. C is not A. So if A equal to 0, C equal to 1. So the first AND gate inputs are C and B. E is the output of first AND gate 0, 1, 0, 0 according to that truth table of AND gate. And to the second AND gate, D and A are inputs and E and F are the inputs of OR gate. Z is the output of this combination. This is exclusive OR gate named as XOR gate, truth table of XOR gate. Truth table of XOR gate, combination of 2 NOT, 2 AND gates and 1 OR gate. And this XOR gate is important for entrance examination, and symbol of XOR gate. A and B are inputs of XOR gate and Z is output.